Dear students, today I am going to tell you about UML diagrams, which is important part in software modeling and design subject. So before starting with UML structure, let's see what is exactly UML is. UML, it is nothing but Unified Modeling Language, is one of the most exciting tool in the world of system development today. The UML enables system builder to create blueprint that to capture their vision in standard, easy to understand way and communicate them to others. System, it is combination of software as well as hardware that provides a solution for business problems. So these are the important terms as we are considering a UML diagram. So first of all, client. System development is the creation of a system for a client. The person has the problem to be solved. Second one is analyst. An analyst document the client's problem and relays it to developer. Programmers who build the software that solve the problem and deploy the software on computer hardware. So this structure shows UML diagram classification. This UML diagrams first of all divides into two parts. It may be your static or structural diagram or dynamic or behavioral diagram. So structural diagram is divides into class diagram, object diagram, package diagram, component diagram, deployment diagram. Then behavioral diagram, use case diagrams, activity diagrams, state diagram, interaction diagram, sequence, collaboration, timing and interaction overview diagram. So working with relationships, as we are considering UML over here, many types of relationships are there. First of all, first one is association. When classes are connected together conceptually, that connections is called as association. Second one is generalization. One class inherits some attributes or properties from another class. The parent's class is more general than the child class. Object orientation refers to this as inheritance. The UML refers to this as generalization. This type of connection standards for the phrases is a kind of relationship. This figure shows generalization. Next one is aggregation. Sometimes a class consists of number of components classes. This is a special type of relationship called as aggregation. The components and the class they constitute are in part of whole association. Example, home computer. This figure shows aggregation. Next one is composite. A composite structure or composite relationship is a strong type of aggregation. Each component in a composite can belong to just one whole. Example, the components of a coffee table, the tabletop and the legs makes up composite. This figure shows composite diagram. Last one is dependency. One class uses another or one class depends on another. That means change in one class that affects changes in another class. Next one is realization. The relationship between a class and interface is called as realization. This is modeled as dashed line with the large open triangle adjoining and adjoining to the interfaces. Now move towards use case diagrams. So use case diagrams is a powerful concept for helping an analyst to understand how the system should behave. It helps you gather requirements from the user's point of view. It shows boundaries between system and outside the world, representing a use case model. The actor, use cases and interacting connections lines makes up a use case model. An actor initiates a use cases and an actor receives something of value from the use cases. Sticks figure represent an actor. An actor names appears just below the actor. Next one is use case. Use case is a collection of scenarios and each scenario is sequence of steps. An eclipse represents use cases. The name of these use cases appears either inside the eclipse or just below it. Next one is association, or you can say that relationship or connections between actor and use cases. So line connects an actor to the use cases and represent communication between actor and use cases. This line is solid, like the line that connects associated classes. This figure shows use case diagrams. Supplier is there, then restock is there. As we are considering use case diagram, in two types of relationships among the use cases. First one is inclusion, second one is exclusion. Next one is activity diagram. The UML activity diagram is much like the flowchart of old. It shows steps of activities as well as decision points and branches. It is useful for showing what happened in the business process or an operations. It's an integral part of system analytics. Elements of activity diagrams are following. First one is starting point, then next one is activities, transition and end point. So first of all, starting point. The starting point or activity diagram has a starting point represented by the field in circle. Activities, it represents by rounded rectangle. More oval shaped than the state icon. And transition, an arrow represents the transition from one activity to the next. Endpoint, endpoint represents by bull eye, that means full covered circle. This figure shows activity diagram. See, start point is there, end point and activities, activity 1 and activity 2, transition is there. Next one is class diagram. A class is a category or group of things that have the same attributes and same behavior. The rectangle is the icon that represents the class. It divides into 3 areas. The uppermost area contains the name, then next one is attributes, and last one is operation. A class diagram consists of number of these rectangles icons connected by lines that shows how the classes related to one another at developer side. This figure shows class diagrams, number of classes and their connections are there. Class diagram, it shows class, attributes and operations. One more example. First class is customer, having their attributes as well as operations. Next one is object diagram. Object diagrams are derived from class diagram. So object diagrams are dependent upon the class diagrams. Object diagrams represents an instance of a class diagrams. The basic concepts are similar for class diagrams. It means the object diagrams is more closer to actual system behavior. The purpose is to capture static view of the system at a particular moment. So these object diagrams having some symbols. The icon is rectangle, just like the class icon, but the name is underlined. In the icon on the left, the name of the specific instance is on the left side of the column and the name of the class is on the right side of the column. The name of the instance begins with lowercase letters. This figure shows object diagrams. Next one is package diagram. Some things you will find the need to organize the elements of the diagram into groups. You might want to show that the number of classes or components are part of particular subsystem. To do this, you group them into package. Next one is representation. You show a package using rectangle with tab attached to the top left. Next one is importing. Importing grants away permission for the elements in one package to access the elements in another package. exporting. The public part of the package are called as exports and represents by plus sign. A package can only export its public elements, no permission for private and protected elements. And last one is transitive properties. This figure shows package diagram. Next one is sequence diagram. Class diagrams and object diagrams represent static information in a functioning diagram. However, object interacts with one another and this interaction occurs over time. The UML sequence diagrams shows the time-based dynamics of interaction. The sequence diagram consists of object represents in the usual way. Messages represent a solid line, arrows, and the time represents a vertical progression. So this figure shows sequence diagrams. See, some horizontal as well as vertical lines are there. Message. A message that goes from one object to another it is nothing but your message. And next one is time. The time represent this vertical direction. Time starts at the top and the progression towards the bottom. This figure shows time as well as message. One more example, it shows sequence diagram. See, components are there, then connections, vertical lines and horizontal lines. Next one is collaboration diagram. Like the sequence diagrams, the communication diagram shows how the objects interact with each other. It shows the objects along with the message that travels from one to another. Difference between sequence diagram and communication diagram. The sequence diagram is arranged according to time and the communication diagram according to space. So an object diagram shows objects and their relationships with one another. A communication diagram is an extension of the object diagram. So this following figure shows collaboration diagram. Actual flow of diagram is from first to sixth activity. One more example on the basis of collaboration diagram. Last one is state diagram. One way to characterize change in a system is to say that its objects change their states in response to event and to time. When you for example, when you throw a switch, a light change its state from off to on. The fundamental symbols for state diagrams: the rounded rectangle that represents state along with the solid line, and arrowhead that represents transition. The arrowhead points to the state belonging transitions into, and the figure also shows the solid circle that symbolize a starting point and the bull's eyes that symbolize end points. Adding details to the state icons. The UML gives you the options of adding details to these symbols. This figure shows state diagrams. Next one is composite diagram. A software component is a modular part of a system because it's the software implementation of one or more classes. A component resides in a computer, not in the mind of an analyst. A component provides interface to the other components. Data files, tables, executables, documents, dynamic links, libraries were defined as a components. This figure shows components. The components diagram's main icons is a rectangle that has two rectangles overlaid on its left side. Types of components are there, and this figure shows component diagram structure. Last one is deployment diagram. Deployment diagram shows how artifacts are developed on system hardware and how the pieces of hardware connects to other. These are the some structure: nodes, process node, device node, lines. This figure shows deployment diagram